Hey guys, here are your day 2 notes on section 8.1, simplifying rational expressions. So I just want to go over a few more examples with you. It's the same thing. You have to factor first because we need things attached by multiplication in order to get them to cancel on top and bottom, except this might put your factoring skills a little bit more to the test. But that's all it is. We're going to look to factor the top, factor the bottom, and cross out common factors on top and bottom. All right, here we go. We have to simplify the following expressions, right? So again, 4x is attached to the 20 with an addition sign. So that makes them a package. A 4x plus 20 could only cancel or reduce with another 4x plus 20. All right, then we have 10x plus 30 on the bottom. Again, they're attached by addition. So they're a package, right? So a 10x plus 30 could only reduce with a 10x plus 30 on top. Again, they want you to start thinking like, oh, look, I can cancel x, I can reduce 20 and 30 and 4 and 10. But you can't do that because of the addition. All right, so let's look to factor the top. Well, again, it doesn't look like our normal 1, 2, 3 piece trinomial, polynomial. This is just 2 pieces. So a lot of times what I want you to see in today's notes is a lot of times the factoring is all about a GCF. What does a 4x and a 20 have in common? What is their greatest common factor? A 4. So factor out the 4 and it's going to leave you with x plus 5, right? If I multiplied the 4 back in, that would get me back to the 4x plus 20. All right, then usually after we pull out a GCF, we would look to factor again, but the factor that is left is linear. It's degree 1. It's x plus 5. Normally our x squareds are the ones that might factor again, so this should be, it should not factor again unless you messed up the GCF. All right, over. All right, what is the GCF of 10x and 30? It's 10. So take out the 10, and now what's left? X plus 3. So normally the easiest things that we see can cancel are the packages. X plus 5 would only cancel with another x plus 5. Since there isn't an x plus 5 in the bottom, that means he's going to stay. There's no way this is going to cancel. X plus 3 is a package. It would only cancel with another x plus 3 on top, and there isn't one. So that means he's not going anywhere. So this and this are definitely going to be a part of our answer, which means the only thing we can maybe reduce are our individual numbers, because guess what? 4 is attached to this by multiplication now. 10 is attached to this by multiplication. So since they're attached to the next piece by multiplication, they are fair game to reduce. So what does 4 over 10 reduce to? 2 goes into both, so they reduce to 2 and 5. So your final answer is going to be 2 times x plus 5 on the top over 5 times x plus 3 on the bottom. So there won't always be like significant canceling and crossing of things out. Sometimes maybe it's just these individual factors now that are allowed to reduce, and that's fine. Don't force anything, okay? All right, let's look at number 2. All right, we have to simplify this fraction, right? Well, if I look to factor the top, 6 and x are already attached by multiplication. So it's already factored, if you will. These are already attached by multiplication. So there's nothing you have to do to that. All right, we go to the bottom. Again, it looks small. We should always be looking for a GCF first. All right, what does a 12x squared and an 8x have in common? They have a greatest common factor of 4, and they both have 1x. So I can pull out 4x. If I pull out 4x, what's left? 4x times what gets me back to 12x squared? That would be a 3x. 4x times what gets me back to a negative 8x? That would be a minus 2. So the easiest one to check first is this package of 3x minus 2. He would only cancel with another package of 3x minus 2 on top. And since there isn't one, he's definitely going to stay. He can't cancel with anything. So then the only other things we are allowed to reduce are the individual numbers and the individual variables. Because guess what? 6 and x are attached by multiplication. 4 and x are attached by multiplication. And they're attached to the next piece by multiplication, which means your 6 and 4 are fair game to be reduced with each other, and your individual factor of x and this individual factor of x are fair game to reduce and cancel with each other. All right, let's do our numbers first. What does 6 over 4 reduce to? Well, 2 goes into both, right? So he goes to a 3 and he goes to a 2. All right, what happens to an x on top and an x on bottom? They cancel completely. So now you're just left with a 3 on top over a 2 times the 3x minus 2 that is still left. and that's your reduced answer, okay? All right, let's go again. All right, if we have to simplify this one, 3AB, well again, that's 3 times A times B. They are already attached by multiplication. So this is an individual factor of 3, this is an individual factor of A, and this is an individual factor of B, all of which are going to be fair game to reduce with individual numbers, individual A's, and individual B's. All right, right now, 6A squared minus 6A, it's a package, right? Because they're attached to the next piece by subtraction. So we're going to look to factor the bottom. All right, so 3AB stays the same. Over, what does a 6A squared and a 6A have in common? Well, they both have a factor of 6, and they both have 1A. So 6A is their GCF. So what's left? 6A times what gets you 6A squared? A. 6A times what gets you negative 6A? Minus 1, right? Okay, so A minus 1, he's a package. It would only cancel with another package of A minus 1. So since there isn't one on top, he's definitely not going anywhere. It'll definitely be in our answer. But that leaves us with attached by multiplication, so an individual 3, an individual A, and an individual factor of B. 6 and A are attached by multiplication, and they're attached to the next piece by multiplication. So 6 is fair game to reduce, and A is fair game to reduce. They are individual factors. So let's do our numbers first. 3 over 6, well, 3 goes into both. So it reduces to 1 over 2. A over A completely cancel out, and B on top with no individual B's on bottom will stay. So on top, I'm left with 1 times B, which is B, over 2 times A minus 1. And that is your reduced answer, okay? Okay, let's keep going. Again, so I feel like it's just kind of putting your GCF factoring skills to the test, all right? Let's look at this example. All right, if I have to simplify this, right? Well, there's lots of stuff they would love for you to try canceling out. But look, 8x to the 4th minus 4x cubed, they're attached by subtraction. So they're a package right now. 2x squared minus 2x, they're attached by subtraction. They are a package. So let's look to factor. Let's look for GCFs first. What does an 8x to the 4th and a 4x to the 3rd have in common? A 4 and an x to the 3rd. If I take out a 4x to the 3rd, that's going to leave me with 2x minus 1, right? That'll get me back to the original expression. All right, now we go to the bottom. All right, what does a 2x squared and a 2x have in common? Well, they have a 2 and an x in common. So take out 2x, and you're going to be left with 2x times what gets you back to 2x squared in x. 2x times what gets you back to negative 2x, a minus 1. Okay, so 2x minus 1 is a package. It would only cancel with another factor, another package of 2x minus 1, and there isn't one down here. So this is definitely going to stay and be part of our answer. X minus 1 is a package. It would only cancel with another x minus 1 on top, and there isn't one. So he's definitely going to stay. So that kind of leaves the individual factors outside to see if anything will cancel or reduce. 4x to the 3rd and this parenthesis are all attached by multiplication. So they are fair game to be reduced. All right, these are individual factors. All right, 2 and x are attached by multiplication, and they're attached to this parenthesis by multiplication. So they are individual factors that are fair game to be reduced. All right, let's do our numbers first. 4 divided by 2, guys, it's 2. So where do whole numbers go? They go on the top. So you're left with 2 on bottom and nothing, 2 on top and nothing on bottom. All right, x to the 3rd divided by x. Well, remember, same base, in division, we subtract our exponents. So 3 take away 1 is 2, and we put it back on top. So this one cancels, and this one becomes an x squared. Okay, and then we're left to see what's on top, and then that's it. So 2 times x squared times this is left on top. And then on bottom, the only thing that's left is the x minus 1. And again, if you're going to be tempted to reduce him with something you're not allowed to, then leave him in parentheses. But you don't technically have to put the bottom in parentheses. And that is your reduced answer. Okay? All right, let's look here. A lot of stuff, right? Again, they want you to be like, oh, look, cancel, cancel. Nope, way too much adding and subtracting. This is a package right now. and this is a package right now. Well, I don't like all these x's to the third, so I'm definitely going to look for a GCF. What does an x to the third, a 6x squared, and a 5x have in common? An x. Take out an x, and that's going to leave you with x squared plus 6x plus 5. That looks like something we normally would have factored. All right, over, what does an x to the third and a 25x have in common? An x. And then that's going to leave you with x squared minus 25. Bells, whistles, sirens, neon flashing lights should be going off because guess what? That's the difference of two perfect squares. All right, so now let's look to factor what's left again, right? So bring over your x, and then let's see if I can break this up into two individual factors. All right, what times what gets me x squared? X, x. The number I put here and the number I put here has to multiply to 5, and then my rainbows have to add up to 6 x's. Well, guys, there's only two numbers that multiply to 5, 5 and 1. All right, and then what kind of signs do I need to add up to 6 x's and multiply to a positive 5? Plus and plus. All right, x times x gets me x squared, 5 times 1 gets me 5, 5 x's and 1 x's add up to 6 x's. So I definitely factored it right. All right, then we bring over the x, and now we try and factor this. It's the difference of two squares, so it always factors to the same two factors, but one's plus and one's minus. So take your square roots. What's the square root of x squared? X, x. What's the square root of 25? 5 and 5, and then I need 1 plus and 1 minus. Okay, so now, this is an individual factor of x. He can cancel with the other individual factor of x on bottom. All right, x plus 5 and x plus 5 can cancel, and then you're going to be left with x plus 1 and x minus 5. And they have to stay because an x plus 1 only cancels with another x plus 1. An x minus 5 only cancels with another x minus 5. So you're left with x plus 1 over x minus 5. And again, if you think you're going to be tempted to cancel those x's out, then leave it in parentheses to remind you that those are packages and they only cancel with something that looks exactly like them. All right? And that's your reduced answer. Okay? A couple more. We're getting there. All right. Let's simplify this, right? So we look to factor first because right now this is a package and this is a package. All right. What does an x squared and a 2x have in common? An x. That's going to leave you with an x minus 2 over. Do they have a GCF here? No, this is finally one that doesn't have a GCF. X squared, x, and 6 have nothing in common. It looks like something we normally would have factored though, right? It's not the difference of two squares. It's not grouping. There's no number in front of x squared. So what times what gets you x squared? X, x, and then you got to put a number here and a number here that multiplies to -6, and your rainbows have to add up to the 1x in the middle. So guys, you have two options. You have 6 and 1, and you have 2 and 3. 6 and 1 will never add up to 1, so it's got to be the 3 and the 2. All right, so 3 and 2. And now what signs do you need to multiply to a negative? That means I need 1 plus and 1 minus. And who gets the plus and who gets the minus if I have my rainbows going to 1x, positive 1x? That means I would need a positive 3 and a negative 2. They multiply to -6, 3 x's and -2 x's add up to the 1x in the middle. So now what happens clearly to the x minus 2 and the x minus 2? They cancel. This x could only cancel or reduce with an individual x on the outside, but I don't have one, so he definitely has to stay. And then x plus 3 is a package. He could only cancel or reduce with another x plus 3 on top, so he definitely stays. And then again, that's your final answer. If you think you're going to be tempted to cross those x's out, then leave this one in parentheses to remind you that it's a package and it can't cancel with that x up there. And you're done. Okay? All right. So I'm just trying to go over just a lot of GCF examples with you to refresh your memory. All right. All right, let's look up here. If I have to reduce this rational expression, right? All of this is a package right now because of all that subtraction and addition. And then this is a package, right? Don't get cross out happy and think, oh, look, boom, boom. Can't do that, right? 18, 18, boom, boom. Can't do that. All right, so if we look to factor, well, we look for a GCF first. What does a 2x squared, an 18x, and a 36 have in common? A 2. So take out a factor of 2. It's going to leave you with x squared minus 9x minus 18. All over. On bottom, what does a 2x squared and an 18 have in common? A 2 again. So take out a 2. X squared minus 9. Bells, whistles, sirens, neon flashing lights. That's the difference of two squares right there. All right, so now that looks like something that can factor again. So let's try to factor it again and get things attached by more multiplication. All right. There's no GCF. We already took it out. It was 2. There's no number in front. It's not the difference of two squares. It's not grouping. So what times what gets you x squared? X. The number I put here and the number I put here better multiply to negative 18. And then my rainbows better add up to negative 9x's. So guys, the numbers that multiply to 18 and 1, but they'll never add up to a 9. Or go to a 9, I should say. 9 and 2, but they'll never go to a 9. What else multiplies to 18? 6 and 3, and they can go to a 9. Let's try 6 and let's try 3. All right, what signs do I need oh, guys, call me out on that. This is positive 36, right? So when I pull out the 2, this should be positive 18. Sorry about that. All right, so now what will make them multiply to positive 18 and then add up to negative 9? Both negative, right? All right, all over. The 2 comes down. X squared minus 9 is the difference of two squares, so take your square roots. You'll get an x and an x. Take your square root of 9, you'll get a 3 and a 3, and then you need 1 plus and 1 minus, so your rainbows add up to the 0 x's in the middle. All right, now, clearly an x minus 3 and an x minus 3 will cancel. X minus 6, no x minus 6, he's staying. X plus 3, no x plus 3 on top, he's staying. But these individual factors of 2 can now cancel. And you're left with x minus 6 over x plus 3. And again, if you're going to be tempted to cancel these x's out, then leave them in their parentheses to remind you they're a package deal. All right? And you're done. Okay. One more. Last one. All right. If I have to simplify this, let's look to factor it. Let's look for a GCF, right? What does a 2x squared and a 10x have in common? A 2x. That's going to leave me with x plus 5. Over, all right, what does a 3x to the third, a 16x squared, and a 5x have in common? Really, they have no numbers in common, but they do have an x, so take out an x. And then that's going to leave you with 3x squared plus 16x plus 5. Okay, let's look to go to the top. Well, what's left is linear. This is a linear factor, degree 1. He's not going to factor again unless you didn't get the biggest GCF, but we did. So he stays the same. 2x, x plus 5 stays the same. Over this factor of x. Now this looks like something we might be able to factor again. So let's try to factor that again and get more pieces attached by multiplication. All right, whatever I put here and whatever I put here better multiply to 3x squared. Well, guys, only two numbers multiply to 3, a 3 and a 1. So I need a 3x and a 1x. The number I put here and here better multiply to 5. Well, the only numbers that multiply to 5 are 5 and 1, but it will matter where you put them. If I put, let me get a pencil. If I put,
Did you make your neon?
where is it? There it is. If I put a 5 here and a 1 there, right? 5x's and 3x's won't go to a 16x. So I can't put them there, so it does matter. So then that means if it can't go there, I better put the 5 here and the 1 there. Now 1x and 15x's can go to my 16. And what signs do I need to multiply to this 5 and add up to that 16? Plus, plus. So now, clearly this x plus 5 and this x plus 5 can cancel. That's the fun part. Now, this 2 could only reduce or cancel with an individual number out front, but there isn't one, so it's definitely staying. This individual factor of x and this individual factor of x can cancel. And then that's it. 3x plus 1 would need another 3x plus 1 on top, and there isn't one, so he has to stay. So that means you are left with just 2 on top, and then just 3x plus 1 on bottom. And again, if you want to leave this in parentheses, you can, and you're done. Okay, all right, guys, that's it. That's the last notes for section 8.1. Good luck, and as always reach out to me if you have any questions.